Okay, algebra kids, I am home again today, but I'm going to try to go through the next like 10 questions with you. So starting with 23, I think we're going to try to go to like the end of 33. And that'll only give us like 7 that we have to do tomorrow because some kids are leaving early for basketball, I think. So that'll be a nice, good stopping point. I have a little helper with me, so if you hear her squawking, that's who that is. All right, so all right, 23, 24, 25, 26, those are all factoring. So these are the different types of the 4 main factoring methods that I'm going to make you do. I won't have you do like sum of cubes or difference of cubes like we did this last chapter with that formula. But like this one is a simple trinomial, so those are ones that we're going to do. For a simple trinomial, you're looking for, I want to multiply to get -8, but when I add them, give me -7. And I'm going to find my 2 bubbles. Okay, x goes here and x goes here. So then I just have to find my factors of -8. So I could do 1 and 8 or 2 and 4, I think are the factors. And so if I'm trying to make 7, I'm going to use 1 and 8, but it needs to be a -8 and a +1. Okay, in order to make -7 when I add them. So I'm just going to put +1 minus 8. There's that, and then the only other thing I have to do is set them equal to 0. So if x plus 1 is equal to 0, and I subtract the 1 over, x equals -1. Okay, you don't necessarily have to show all your work for that if you don't want to, but x minus 8 equals 0. That means if I add the 8 over, x equals +8. Okay, so there is that. That was a simple trinomial that we are breaking down. 24 is only 2 pieces, and one thing I noticed is there's a minus between them. That tells me difference, okay? And I can take the square root of x squared, and I can take the square root of 16. So this is a difference of squares, okay? Difference of squares, when you break it down, you have 2 bubbles. This one's really fast. The square root of x squared is x, so that goes in the first spot. The square root of 16 is 4, and one of them is going to be plus and one of them is going to be minus. Then if I set like x plus 4 equal to 0, and I subtract the 4 over, I have x equals -4. That's one of my answers. And if I do this, x minus 4 equals 0, and I add 4, x is going to be +4. Now, some of you might wonder, like, hey, if I start with this, do I have to factor it down, or can I just like add the 16 over and then take the square root? You certainly can, but just don't forget when you take the square root that it's plus and minus 4. So you are more than welcome to do that as well. That's the same like way of solving for a difference of squares. Either way works. You should get the right answer, but just don't forget your plus and minus when you're doing the square root. Okay, so that's totally legal as well. That was 24. All right, 25 is not it's a difference. There's a minus between them, and there's only 2 terms, so it's not a trinomial, right? There's a minus between them. But I can take the square root of 4, but I can't take the square root of 20. So that's making me think it's not a difference of squares. But one thing I notice is that those 2 pieces, I can pull something out of it. So this is going to be a greatest common factor. And what I'm going to take out, I can take out a 4, but then I can also take out an x, okay? So if I take 4x out of this guy, I'll have an x left over. And if I take 4x out of 20x, that will be 5. Equals 0, okay? Now that I have my 2 bubbles, now technically 4x is a bubble in itself, right? We just don't usually put them in parentheses. But I have like 4x is equal to 0, and x minus 5 is equal to 0, okay? If 4x equals 0 and I divide by 4, x is 0, because 0 divided by 4 is still 0. This guy, if I add the 5 over, I get x equals 5. So those are my 2 answers that I get, okay? Now, just keep in mind that as we're doing this, what we're actually finding is where the zeros are, or where the x-intercepts are. That's the whole thing of what I'm doing, okay? I got it. See, there's my helper. Okay. Here we go. Hold on just a second. Yeah. All right. Okay, let's go back to 26. Okay, this one is the last one of the methods that we have, and this one is the complex trinomial. Whoa, where did my stuff go? Oh, I'm on the wrong pen. Okay, complex trinomial. Because he's a trinomial, he has 3 pieces, and there's a number in front of my x squared, so that's what makes him complex, okay? So when we're doing complex trinomial, we take the first number and multiply by the last number. So 3 times 5 is 15. And then I want to find numbers that multiply to give me 15, but when I add them, give me 16, negative 16, okay? So I could do 1 and 15, I could do 3 and 5, and those are my only numbers that I can choose. But the numbers that I want to make 16 are going to be 1 and 15. If I want it to be negative 16, I'm going to do negative 1 and negative 15. All right, so when I write this out, 3x squared, this guy just comes straight down, and the plus 5 is going to come straight down. But this 16 is going to break into these two pieces, which is minus 1x minus 15x. If I put those two together now, I would get minus 16, okay? And then I factor by grouping. So I group these two and group these two. Out of this chunk, this first chunk, I'm going to pull an x out, and I get 3x minus 1. Out of this second chunk, if I try to pull a 5 out, I would get negative 3x plus 1. But I want these two to match, right? So I'm going to take out a negative 5. And when I take a negative 5 out, that's going to turn this to be positive 3x. And this plus 5 is going to turn to minus 1. Okay, so now my two bubbles match each other. Okay, and my two bubbles are 3x minus 1 and x minus 5. Okay, then if I set that equal to 0, I'm going to do that over here. 3x minus 1 equals 0, and x minus 5 equals 0. This one, if I add the 5 over, I just get x equals 5. So that's one of my answers. This one, if I add the 1, 3x equals 1, and then divide by 3, x equals 1/3. Okay, if I'm going too fast, feel free to pause or, whatever you need to do to get caught up. But make sure also as you're going through here, if there's ones that you don't understand and you're like, how the heck did she get that? I don't get that. Put like a star by the side and say, let's go over that tomorrow when I'm back again. Okay, so I told you that for the first section thinking that I was going to be back today, but I'm not. So tomorrow I will hopefully be back. I'm going to force myself to be back. And we will go through those questions if you have questions that are starred. So as you're going through these, if you don't understand what you're doing, please star them, and then we'll go through them again together, and I'll give more clarification or more explanation. All right. 27 says, find the value of c. C is right here. That makes this thing a perfect square. Then write it as a perfect, write the trinomial as a perfect square. Well, yes, I know. What? Okay. So this is like the steps that you use when you're completing the square, but I'm not going to actually have you complete the square. What I want to do is I want this thing to break down into two chunks that when I multiply, I get this number right here, c, but I don't know what c is. And when I add them, give me 18. Now, there's lots of numbers that you can add together to give you 18, like 1 and 17, or 2 and 16, or 4 and 14, or whatever. But I want these two to be the same so that I can write it like that squared, okay? So I want two numbers that add together to be 18, but they're the same number. So basically, it's like taking 18 and dividing by 2. So this has to be x plus 9 and x plus 9, right? So then I can write that as x plus 9 squared. They want me to write it, then write the trinomial as a perfect square. X plus 9 squared, that's that part. Now, we still have to find the value of c. I usually do that last. If this guy's 9 and this guy's 9, 9 plus 9 gives me 18, but 9 times 9 will give me this number, and that is 81. So my c value is 81, and then I can write it as this bubble squared. So hopefully that made a little bit of sense. It's kind of like completing the square, but I'm not actually going to have you set it equal to something, whatever, okay? I won't make you do that, all right? 28 is talking about the discriminant, and 28 and 29 go together. So that's another set of problems that those two will show up exactly right next to each other on the test. Kind of like up here we had these three went together. So those will be together on the test. These two will go together because they're talking about the discriminant and they're talking about the quadratic formula. So I'm going to go down to 29 and I'm going to talk through the quadratic formula really quick. Quadratic formula is negative b. Make sure you write this down. Plus minus square root b squared minus 4ac all over 2a. So then all we have to do is get our a, b, and c from this problem, plug them in and solve. But 28 is asking specifically for the discriminant. And the discriminant is just the stuff that's underneath of the square root. The discriminant is b squared minus 4ac, okay? Now, that number, whatever I get for that number, is going to tell me some things, okay? So, for example, if that number is a positive number, this number would be positive. I'm going to end up with, that's going to give me two solutions. The two solutions come from plus that number and minus that number, right? Like those are two answers, okay? So if it's positive, it's two solutions. If it's negative, I would end up with a negative number inside here, and you cannot take the square root of a negative, which means I'm going to end up with no solutions. He's not going to cross the x-axis, okay? If that answer is 0, I'm going to have like 0 in this spot, and something plus 0 is the same thing as something minus 0. So I really only end up with one solution, okay? So that's the little kicker to, I'm going to erase that, one solution. That is the trick to what the discriminant tells you, okay? So like as far as a graph goes, when I have two solutions, my parabola is going to look like this, where it's crossing two places. Where he doesn't cross at all is going to look like that. Okay, he's like levitating. He's not crossing this x-axis. And whereas one solution, the vertex is on the x-axis. So that's what he will look like, okay? And I can figure out which one of those are occurring just by computing the discriminant, just by doing this part, okay? So that's what we're going to do over here, all right? Out of this stuff, let's find A, B, and C. Okay, my A value is the number that's in front of x squared, and there's no number, so I assume it's 1. B is going to be this number, which is 4, and C is negative 32. The 32 goes with it, or the negative goes with it, okay? So if I'm doing B squared minus 4AC, that will be 4 squared minus 4 times A is 1, and C is negative 32, okay? All right, now I got to do my math. 4 squared is 16. Negative 4 times 1 times negative 32, that's going to be a positive number, and that will be 4 times 32 is 128, I believe. If I add those two together, I get like 144. Yeah, 144. There we go. Okay, so my discriminant is 144. They ask you to find the value of the discriminant. We just did that. Then it says use this to determine how many solutions, okay? So 144 was my discriminant. Is that a positive number? Is it a negative number? Or is it 0? 144 is a positive number, so I'm going to end up with 2 solutions. He's going to cross 2 places. 2 solutions, okay? All right. Now, they want me to actually do the whole quadratic formula to solve what those solutions are, okay? So I have the same problem again. I have the same equation as I did up here, and I'm going to use A, B, and C. A, B, C, 1, 4, negative 32, and I'm just going to plop them in here, okay? If B is 4, then negative B will be negative 4, plus minus the square root. Now, don't redo this whole stuff again. We've already done B squared minus 4AC. We found that it was 144, so don't do the whole problem again, okay? Times 2A, and 2 times 1 is the bottom, okay? Now, 144 does come out nicely as 12, the square root of 144. That does come out nicely. If it doesn't come out nicely, you're welcome to just leave it as the square root of whatever, right? So just leave it like that. So we have negative 4 plus and minus 12 all over 2 times 1 is 2, okay? Now, because that came out as a nice number, I'm going to actually give 2 answers. Negative 4 plus 12 divided by 2 and negative 4 minus 12 divided by 2. That's what my 2 answers will look like, right? If I do negative 4 plus 12, this is 8 divided by 2. So that answer comes out as 4. And I forgot my 2. 2. Negative 4 minus 12 is negative 16 divided by 2 is negative 8. So those are my 2 answers. I said I was going to get 2 solutions, and I did. Okay, so just so you're aware what it is that we just found, negative 8, 1, 2, 3, 4, 5, 6, 7, 8, that's a place where he crosses. 4, 1, 2, 3, 4 is a place where he also crosses. So my parabola is doing something like this. Okay. So that is what we found. Those x-intercepts, or the zeros, is what they're called, okay? And we did that using the quadratic formula, all right? Now, some of you guys might be asking, well, hey, this is actually a simple trinomial. Could I just have done, what do you multiply to get 32 and add to get 4? Yeah, because it came out nicely, that means I could have done it by just factoring, right? Negative 8 and 4, or what I multiply to get 32, but add to get 4, right? Like, that's how I could have done that. Now, most of the time when you're doing the quadratic formula, you're doing it to problems that the square root doesn't come out nicely. That's the whole purpose of the quadratic formula. But for some reason, they gave you one that does come out nicely. So that's just a nice thing because you can check your answer, right? You're like, oh, that makes sense because I could have actually factored that instead. Whatever. Okay, moving on. 30, 31, 32, 33. We got 4 left. Okay, this one's a multiply. We have a binomial, which is 2 pieces, and a trinomial. There's 1, 2, 3 pieces there. And 2 times 3 is 6, which means I'm going to have 1, 2, 3, 4, 5, 6 pieces when I multiply this, okay? First thing I'm going to multiply is x. I'm going to take him times x squared, like this first piece times this first piece. I do like that first rainbow. X times x squared is x to the third, okay? Then I keep going with my x, but I'm going to take him times the second piece. X times negative 2x is negative 2x squared. And then I take him times the last piece. X times negative 3 is negative 3x, okay? Now, he is done, and I'm going to start with the negative 2, and I'm going to do the rainbows there also. So negative 2 times x squared, negative 2x squared. I take negative 2 times negative 2x, which is plus 4x. And negative 2 times negative 3 is plus 6. Excuse me. The very last thing that I do is I combine like terms. So x cubed, he doesn't have anybody to go with, so I'm just going to write him like that. Negative 2x squared, he will go with negative 2x squared, which will make a total of negative 4x squared. So he is done. Now I can put negative 3x and positive 4x, which is plus 1x, or just plus x if you want to do it that way, and then plus 6. This is my final answer, okay? That was multiplying. That was like, it's kind of like the FOIL method, but you have like an extra 2 steps in there. FOIL, F-O-I-L, is only 4 pieces. This one had 6 because we were taking a binomial times a trinomial, okay? So it's kind of like the FOIL method, though. So there's that. All right, this next one, simplify. Have we done one like this yet? Or we're just subtracting? Yeah, right here, number 20. We subtract. This problem is like basically identical to this problem. You're just subtracting. So I said before, we just distribute the negative through. Okay, so this 4x squared is going to become negative 4x squared. The 7x is going to become positive 7x, and that's going to become minus 1. This stuff's just chilling. He's just waiting for the second half, okay? These don't change sign. Now I just combine like terms. After I distribute the negative through, we're just subtracting. We're just simplifying. So I'm going to combine like terms. 2x squared minus 4x squared is negative 2x squared. That's done. 3x and 7x makes 10x. And negative 4 and negative 1 is negative 5. So there is that. Okay. All right. Next one. 32. Identify whether it's odd or even and positive or negative. Okay. This is what we're going off of. Okay. Odd means he's going opposite directions. Even means he's going the same direction. Okay, so this one is going opposite direction. What I mean by like directions is like one side is going up, one side is going down. In order to be going the same direction, they would have to both be going like this or both be going like this, right? Like this is going down and down or up and up, right? That's what an even function would look like. So this guy's going opposite directions. One's going up on the left and down on the right. So he is going to be an odd function. Okay, and then whether he's positive or negative. So is he going uphill from left to right, or is it going downhill from left to right? So if I look at the general direction that this thing's going, he's up on the left, down on the right. So I mean, like the general direction is going downhill. So he is going to be odd and negative. So what that means is that his degree is odd. So maybe he's x to the 3rd power. Maybe he's x to the 5th power, or x to the 7th power, or x to the 9th power, right? He's probably going to be x to the 3rd power because typically that's what he looks like. And also he's negative. So that means he's negative x to the 3rd power. Okay, so I can figure out what this is called a parent function. I can figure out what the parent function looks like based off of what direction he's going and how what his two end behaviors look like. Okay, up on the left, down on the right, that type of thing. Okay, this guy identified the leading coefficient, degree, and end behavior. So this is kind of doing the opposite of what we did there, right? So the leading coefficient. First thing I'm going to do is make sure that this is in order. So x to the 6th power is my highest one. Yes, so he's in order. So I'm looking at this first piece. I don't even care about anything that comes after that. All that stuff is doing is just like making extra loops and humps in my graph, right? That's all that extra stuff does. But I'm looking at the first term, and this guy is negative, and he is an even function because he is to the 6th power. So I'm going to do like a little rough sketch. If he's even, that means he's going the same direction, and negative means they're both going down. So like he's going to be down here, and he's going to be down here, and I have no idea how many humps he has in the middle. Something like that maybe, right? Okay, but negative, both tails are ending down. Even means they're both going the same direction. So that's what he looks like. Now, since I've done the leading coefficient is -3. The degree is 6. Those are two things it asked for, and that helped me determine what he looked like. And then I can do end behavior. As x goes to infinity, the y is going to something. As x goes to -infinity, the y is going to something. And I just have to figure out, based on this graph that I've created from the degree and leading coefficient, I know that the graph kind of looks like that somehow. So as x is going to the right, he is going down, so he's going toward -infinity. As x is going to the left, he is going toward -infinity as well. He is going down and down. So leading coefficient, degree, and end behavior is what they wanted there. So those are my 3 pieces, and that's it. Hey, there you go. So we only have a little bit left, and most of that stuff is going to be the stuff that we've just recently done. We've only got 7 questions left, but like long division might take a little bit of time. Synthetic division might take a little bit of time. So we've got a little bit of work to do tomorrow, but hopefully we get an early because I think basketball leaves early. So make sure that you star anything that you did not understand. We'll go through it tomorrow. And also, it's not a bad idea if there's time left in class today or right now to attempt some of these. Like, you can figure out what some of those are. Attempt to do your synthetic division. Then we'll check your answer tomorrow, okay? So use your time in the last bit of class to fill those out. That will only help you study for the test, okay? All right, goodbye.